West Africa, I think, you know the places that were involved were Congo, Brazzaville, Nigeria, and the AGC. And again, just as a reminder, the AGC is a joint commercial zone between Senegal and Guinea-Bissau. In Congo, Brazzaville, most of this stuff I'll talk about, I think, in these next slides. But I think just the key thing here is this last bullet. Mike mentioned it also in his opening remarks regarding that we have a very active new venture program or business development in the Middle East and Africa, but definitely concentrating on the places that we're already involved. It's obviously, once you have a base, it's a lot easier to expand. So we're very actively looking at opportunities in these countries. So we'll just jump right on into Congo Brazzaville. Here we're in 2 licenses. It's shallow water out to a bit deeper water. Primarily the plays here are these tertiary turbidites and Cretaceous carbonates. The tertiary turbidites are throughout the system here. And there's other blocks that have them that they're being produced from, like Total and the Moho Balondo field, Chevron in Block 14 on the Angolan side. So the 2 blocks, the Hotmare B block and the Hotmare A, as it says in Hotmare A, we have 20%, and in Hotmare B we have 30%. In Hotmare A, CNOOC, the Chinese National Offshore Oil Company, is the operator. Hotmare B, Total is the operator. Now here we have the Nkosa field. We have the Chevron Block 14 discoveries producing fields in the Angolan waters. And then here we have the Chevron Block 0 fields. Also, some of these carbonates, mixed clastic, siliciclastic systems. So here, these 2 blocks are surrounded by producing oil fields. So it's a very good neighborhood. We see the same turbidite channels going from Block 14 into the HMA block. We have here in the Moho Balondo, Moho North block, we have a series of turbidite channels in between the turbidite channels of the 2 blocks. So this is like I said, a very, this is a known hydrocarbon basin, lots of discoveries, lots of producing oil fields around here. In this year, in 2013, we've drilled 2 wells on Hotmare A and shot a 3D seismic in Hotmare B. And let's just go to the next slide here on Hotmare A. The 2 wells, this is pre-drill. We see an elephant, which is this channel coming through here. Well, actually, all this yellow is a series of different channels, and one of them is the elephant channel coming through there. So Netherland Sewell in just the one channel had 86 million barrels of unrisked prospective resources. Again, it's a turbidite play. It's an extension of the channels that are coming from Angola. There was a previous discovery, Libanolo field. This was drilled by Total in the late 90s. It encountered oil, but a heavier oil. So the numbers that Netherland Sewell came up with were actually based on the same sort of oil that Libanolo discovered, which is, like I said, a heavier oil, and because of that, it has a much lower recovery factor. And then the Horse prospect. This is, Netherland, Sewell had 70 million barrels here. It's a bit outboard, a little deeper water. It has two targets, both the tertiary turbidite and Cretaceous carbonates. And this well was spudded in October. So first the Elephant well was drilled, then we moved to Horse, and currently what we've done is we've gone back to Elephant to do the tests on that well. While we have this map, I guess I'm gonna jump ahead and say, well, the Elephant was a discovery, and Horse was not. And just while this map's on up here, I just want to make a point. And the thinking here is that this part, where the Moho Bilondo fields are, this is actually the area where the hydrocarbon is being charged from. Not necessarily these fields from below that, but what's happening is that the charge is coming from this trough, moving this way and that way. So from a charge perspective, the closer you are to here, the better. So one would imagine that these fields here would have a lot stronger chance, or the likelihood of these being charged is greater than if you're out there. Well, and then I'll come back to that. I just wanted to use that map to show that. Now, okay, so the Elephant well, this is shallower. It only to 2,500 meters. It drilled through three of these channel sequences, the N5, N3, and N2. The N2 was wet. The N3 and N5 both had oil in it. The N3 oil appears to be a good quality, lighter oil. The N5 a little bit heavier. 18 API, but that's a lot better than what Libinolo had. I think Libinolo was around 13. So again, like I said, when Netherland, Sewell applied their numbers, they applied it based on Libinolo type oil, much lower recovery factors associated with that. So where we say the results were consistent with expectations, from a geological perspective, that was very true. The one thing that we do see is that the aerial extent of this channel is a bit smaller than what was previously thought, but one of the things that we do see is we have better permeability, better porosity, better oil type. So all that would also point to a higher recovery. So our post-drill numbers are actually higher than our pre-drill numbers, which is it's a good thing. Now, especially, like I said, we're now getting on to test, and if the test confirms what we think, we believe that this will lead to a commercial development for Elephant. Now, Horse didn't do as well. We drilled to the Tertiary and the Cretaceous. Everything was wet. So this now has been P&A'd. Like I said, we've moved back to Elephant to test. But two things did come out of this that was interesting. Well, the one about the no hydrocarbons. So we knew that the two risks here are reservoir and charge. And we knew that we're farther away from the pathway of the oil, from the oil that was migrating up through. But we also, a big question was regarding the reservoir quality, especially in the Cretaceous. Most people thought that by the time you get to that depth, the porosity it'd be so tight that you wouldn't have reservoir. And one of the things that even though we didn't have the hydrocarbon charge, we did have very good reservoir quality. So, even though what this points to is that, okay, this didn't work, but if we move closer to the belt of channels that are closer to the source of the oil, where we have a higher chance of success, in terms of the charge. We know that we have the reservoir quality, so we have what this has done, even though it was an unsuccessful well, it has de-risked some of the other prospects that we have on the block. So like I said, right now we're back on Elephant, and we're getting everything set up so we can start the testing. I mean, hopefully, if everything goes well, the testing will start in the next days to come. And so the Hot Mare B, this has been a bit slower going, and a lot of that has to do just with getting all the paperwork through the system. But this year we were able to get, in the summer we got the presidential decree. Since then we've been able to everything's been signed, and it's we have a JOA that's signed between the partners, and there's still a couple formalities that need to happen in regards to the paperwork for the block, but it's signed. We've had our first official technical committee meetings between the partners, some workshops. Like I said, the 3D seismic has been shot over the block. The processing is being done, but the fast track processing has already been finished and interpreted, which has better clarified some of the prospects we already had, and has identified a couple new prospects. One in particular that might, the goal had always been between the partnership and our discussions that this Kaki Main would be the first prospect drilled. But from the seismic, we actually see another prospect on here that looks even bigger, more promising. And so we might actually switch out. Maybe Kaki Main will not be the well that gets drilled, the first well, but this other prospect that's been identified, which obviously it was never included in the prospective resource numbers that Netherland Sewell did. But Kaki Main still, is a very good prospect. We're looking at 120 million barrels of unrisked prospective resources. It's a Cretaceous carbonate play, which is like the Encosa field that's here, which is a billion-barrel field that Total operates. Same sort of thing. And like we said, we have the seismic data, and that's going to be used to identify which prospect is number one. So the plan for next year will be to drill a well, at least one well, and it's probably in the middle of next year. The rig has already been contracted. It's doing some work up here for Total, and the plan is when it finishes those wells, it'll come over onto Hot Mare B and drill a well there. Moving to AGC, here again the block. It's a large block, several prospects. We have 80%. The government has 20%. We shot a seismic, 3D seismic survey over this block. It's being processed. Talk a little bit more about the importance of that. But in the meantime, we do have process cubes that we're working on the interpretation, further refining the prospects on the block. Now, the numbers that are represented here, these were the numbers that Netherland Sewell came up with that are from the prospectus timing. I think what you'll see now that we spent more time with this is that some of these numbers will probably change a bit. And also, there's one significant prospect that will be added to the list that has come out of the seismic data that we have in-house. The play, the reason we got in here is that, we knew there was these salt domes. We know that there's a working hydrocarbon system here because there's natural seeps, but the main thing is on dome floor, there's on top of the dome, there's heavy oil. People have been drilling this dome since the 60s right on top of it, and have, every time they drill, they find this heavy oil. Companies that have held on to this area, whether it was from AGC or maybe from the Senegal or whoever had awarded the block in the past, and they carried anywhere between 500 million and 1 billion barrels of reserves based on that heavy oil. but never did anything with it. But I mean, you have a massive amount of oil that's just sitting there. The play that we're going after, I mean, since we know we have an active hydrocarbon system, is looking at the flanks of the salt domes. I mean, it's very analogous to the Gulf of Mexico about 10 years ago. I mean, this was something that was very prevalent from a play standpoint there. Shallow water, it's easy to get into, relatively cheap. And then also, just south of where this map ends is you're in the Guinea-Bissau waters. There's a well that was drilled in Sinapa. I mean, this is it's a light oil drilled on a flank of a salt diapir there. So I mean, it shows that not only Gulf of Mexico, serves as an analog, but even right here within the area, we have an analog. The thing about the Sinapa one, it's I guess a bit small. The company's going to drill an appraisal well, but they've been sort of slow to react. The thing, though, in terms of what we're looking at, the structures we have are quite a bit bigger than the one that was drilled in Sinapa. So we're optimistic that volume-wise we're looking at more than what they had. So the plan now is to finish this interpretation. Get all the data in house and finish the interpretation, and then middle of next year is to drill a well. I just kind of go through a few slides that just show the seismic data, and this is from the new data, and you can see. I mean, you have these sand shales, coming up against where you have this salt dome. So the play is, like I said, we go up against the flank of the salt. The salt acts as a seal where you have oil trapped up against, and hopefully if you drill down along the flank, if the oil's there, you're going to find it. Now, we have in-house, we already have the pre-stacked time-migrated cube. This was from the data that we shot. This is what we've been using in-house. This is what was passed to Netherland Sewell for them to do their work. The other thing that's ongoing and it's still being worked on is the depth-migrated cube. And for this sort of play, this data is critical. We get a pretty good estimate of things from the time-migrated cube, but the depth-migrated cube gives us the real understanding, and I'll in the next slide I think it'll illustrate that better. But so we definitely need to get this data in-house so we can finish up the interpretation. So this just shows, this is a time slice, so you're looking down just like you would on a map. You see the domes, you see some bright amplitudes around the domes. So here we have our the three main domes on the block, and we have prospects associated with on the flanks of each of those. And one of the things that has come out of the seismic is a new play, and it's a seismic amplitude related prospect, and it's above the dome iris. So the Albion are the sands. That's the age of the sands that are deeper along the flanks of the salt, and the Maastrichtian is above the salt dome. So we have a very large opportunity in the Maastrichtian above dome iris. So this illustrates this, I guess, the importance of having a depth-migrated cube. What you see is you have the salt, and you see that these sands come up, and on this cartoon it shows, it's coming into the salt in a very steep manner. Now, typically, you're not going to have that sort of, it's really not going to look like that. It's going to be a bit more, it's going to be more gentle. But in the time-migrated cubes, this is the way it looks, because the velocities, you have this contrast of the velocity of the salts versus the sands and the shales. So this area here tends to be really affected by the velocities. So that's why if you process it in depth, it'll make this look it'll make it look more real. And that what's critical there is because that will help you better understand the volumes that you're targeting, and where to place your well. You can imagine, I mean, with something like this, you could very easily place your well in the wrong place if you were using this picture to try to place it. So just to very quickly go through, I mean, these three prospects. I mean, they're the three dome ones. They're all the same. They're all the same in terms of the sort of play type. You have the salt that acts as a seal on one side, and then above you have these deltaic shales. So they're forming the seal above the sand as you go away from the salt dome. The prospective areas do not include the salt. So I mean, if you look at the area here, you subtract the salts, and you end up with about 8.3 square kilometers of area. And all three of these are the same: the dome floor, dome Gea, and dome iris. The thing though is before this data came in, if you go back to the numbers Netherlands Sewell did, dome floor was the largest of the prospects. But now with the new data, we see that dome Gea actually has a lot larger area. So again, like we said, we're going to see some refinement of some of these numbers that we had before using this data. And that's dome iris. And then above dome iris, we have this Maastrichtian sand, and it's a large area on top. And I mean, if this were to play out right, you would expect here that this would be a better quality sand. It's actually a much more attractive target, an easier target than the others. So we haven't prioritized how we want to drill this block up yet, but right now this might, whereas drilling on iris might not have been our first choice as a dome, that might change because we'll have two different targets here to go after. And when somebody asked me, well, how is this different than what's on top of dome floor? I mean, okay, we know that, you go up shallower in dome floor, we have a whole bunch of oil, but it's heavy. It's degraded. I was asked, well, what makes you think that this won't be the same? Same sort of thing, you're above the dome, maybe you have oil, but it's degraded. And in dome floor, the burial depth to the heavy oil is between 200 and 300 meters. Here, the Maastrichtian here is between 800 and 1,000 meters deep. Now, not water depth, but burial depth. So you're deeper. The other thing is it's closer to the dome itself. And one thing about salts is that they tend to generate heat. So by keeping you're deeper, and you also have heat coming from below you. Hopefully, it's kept things hot enough that it keeps the bacteria out. So as you get shallower, like above dome floor, you just have the perfect conditions for bacteria to start working on the oils, and that's why it's biodegraded. So hopefully, here, it is a risk, but the conditions are a bit better, and hopefully we've been able to preserve a bit more of the oil. So again, we're continuing to work on the interpretation. We're waiting on this the depth migrated cube, and we should be that should be coming in the next month or so. We'll finalize on the well location. We have to go through the rig tendering. We haven't contracted a rig, but there is another operator in the area that's looking at drilling a well sometime next year, mid to third quarter. So we're talking to them about how we could share a rig, and we've also already started. We'll probably set up our base of operations in Senegal. So that's something that needs to be done. Working in Nigeria, it's very easy because you have a very well-established industry. It's easier to go set up the port that you're going to be sending everything out and everything. Senegal is not quite the same, so we're already going in and starting to talk to people and figure out how we're going to set up the operation to run out of Senegal. the last point, which is one of the most important here, is if we do have a successful well, I mean, this would be very important to us, and I think these bullet points identify why. One, we do have 80% of the block. So it's a big thing. It would definitely be material for us. If we drill one of these domes and it comes in, it definitely de-risks the others. It adds to the likelihood and I think the excitement behind what we have here. And obviously, I guess the last point here is if we do find lighter oil that supports putting a development out there, then all of a sudden this heavy oil that's out there, this close to 1 billion barrels of heavy oil, you might actually be able to do something with it. On its own, it's hard to justify a development. But if you have light oil that helps justify that development, all of a sudden it puts that into play. Nigeria, OML 141, again, it's a very large block. We're the technical partner, which actually means that we are we're not the operator, but we are operating the block. The operator is Emerald Energy. This is an Nigerian indigenous company, as is Amni Oil. Again, it's a very large block. It's here's the shoreline, so it goes from the shore out to about 30 meters of water, maybe a little bit more than that. This year, we drilled the Dilo prospect, which is out here. We did discover oil, but as a standalone development, it's not enough. I guess the good part of that is that there's quite a few other prospects in the same vicinity. If we drill those and find oil, there's definitely enough oil in Dila that would support a couple wells being tied back. So this is something just to keep in the back of our minds for the future, if anything else works out in that area. There's quite a few other prospects on the block. Netherlands Sewell didn't look at all of them. At one point, I guess they only looked at 6 of the prospects, so 5 remaining of the prospects that go into this 208 million barrels. But there are quite a few other prospects on the block. What we've been doing is taking what we've learned from Dila and looking again at these prospects to better understand this 3D seismic. We had the final cube in-house, but we didn't have access to the raw data. This year we were actually able to get our hands on the raw data, which have now allowed us to do a lot more analysis with the seismic. So it's definitely and combined with the Dila well, we've been able to do a lot more work, and we have a lot better understanding of what's happening in this area. The other thing, though, is we do still have a large part of the block that has no seismic coverage. So, from our perspective, probably the thing to do is to go out and get some more seismic, have a better, thorough understanding of this block before we start drilling again. And I think this just reiterates that we need to spend some time and look at this. And you can see that, here we have some 2D lines, but there's a tremendous amount of area here that has very little seismic coverage. And even here with these 2D lines, we have prospects here, but it doesn't define them at all. So, all right, just to summarize West Africa, we said Congo, Brazzaville, Elephant, we're getting ready to test now. And we have an exploration well planned mid-next year. AGC, the seismic processing, is getting wrapped up. And again, another well there mid-next year. Nigeria, we're looking at some more seismic and continued just work on it to better understand the block and the opportunities on it. And like we're saying, we're actively looking at opportunities. We definitely want to grow our footprint and we are looking at growing our footprint, I mean, actively, even today on the table, looking at opportunities in all three of those countries or regions. I guess just, so that's moving off the assets, just 2 slides regarding where we are on reserves. This is the picture, when we went out with IPO. We see all the DEMERDAG, as we pointed out earlier, has the contingent resources and reserves associated with it. The other opportunities, both in the hauler block and on the other assets, all are sitting in prospective resources. So this is where we were at, first quarter of this year. So, like I said, we're going to have an end-of-year report coming out from Netherland Sewell. We will see some changes. I'm not going to. I mean, we're not. We're doing our own internal work. They're going to do theirs. So I can't really speak to exactly how the numbers will change, but we do see potential reserves coming from DEMERDAG, Zagara, and Ain al-Safra from the exploration wells there. Also, contingent resources from those, and Banan, and also Elephant, maybe even reserves, depending on how the tests go and when we complete the test. If hopefully we'll complete it by the end of the year. And then some additional prospective resources or Banan. This is that extended area, and AGC, just because we do have some changes happening there in the interpretation. And this is just another way to look at the same thing. But you see, we have reserves, contingent resources, and this exploration out. And this is all near-term activity. For the most part, this is what's happening today through next year. And what you see is, like I said, a lot of activity, a lot of potential movement of our prospective resources into contingent and reserves based on the work program that we have going forward. And again, just near term, this is just within this next year. So I mean, for us, I think it's extremely exciting. I mean, we've had a very exciting year.